So before I completely destroy this thing, I wanted to kind of look at the different components. So you can see on either side we've got here, and then same thing on the other side. These are the brush boxes. So you can kind of see as I spin this fan here with my fingers, you can see that little rotor in the middle is moving. You'll notice it's segmented. So you've actually got these little, they're called brushes. They come out of those brush boxes and they make contact here. And that actually determines where the current is flowing through in the coils of the motor. And basically it creates a magnetic field inside the motor that points just ahead of where the main coils that you can see here want to be. So it basically it's constantly pushing the rotor forward. And the great thing about a mechanical rotor is no matter how fast you're going, you're always switching those coils at just the speed to keep pushing you forward, and then eventually, just friction and resistance are going to. Not to mention I think electrical inductance plays a large role in how fast you can actually energize those coils. That's kind of what limits your motor speed. So I mean that's a pretty cool look at a small electrical motor. Also, a couple other things I wanted to point out inside the coil. So you can see right there, you see that silver-looking tube? That is a one-time fuse. I'm pretty sure it's a one-time fuse. I believe these are called NTCs for, is it non-programmable or non-resettable thermal cutoff? It's one of those two. But basically, there's a little ball of wax in there that is holding an electrical circuit together. And if that ball of wax melts, the electrical circuit falls apart. So that kills your system. So that is an emergency stopgap. If things get too hot, it can shut everything down and it'll not work again. Obviously, this is not the best solution for a consumer facing a sort of one-time failure, right? Because you can't fix it without taking the whole thing apart. You basically just have to buy a new one. But that is why we also have over here, let me see if I can get you a good view of it. You can just barely see it in there. Let me see if I can get some more light on it. There we go. So this is a bimetallic thermostat. You can just barely make out that there's sort of two different sheets of metal in there. So when this gets hot enough, it's going to peel away and open an electrical circuit. And then when it cools down, it's going to close again and reclose the circuit. So this opens before your wax melts. So that is what gives you your sort of one-time failure protection. And then if this should fail, that's your ultimate fail-safe to make sure that your device doesn't, burn your house down. We've got these multiple switches here. I'm gonna have to come up with a diagram for these, but you can tell just sort of following that brown wire. That brown wire goes to the heating coils, which makes sense since this brown wire is connected to this box, which is advertised as the cool blast button. So basically, you push this button, it opens this circuit, it turns off the heating coils, and now those coils are going to cool off, and now it's just blowing, room temperature air onto your hair. And then, we've got our heat. We've got our heat setting button. I'm guessing this just turns on some sort of different resistance path to deliver more or less power to the coils. The heating coils, and then we've also got your fan speed control over here. Where is it? There you go. We've also got our fan speed control over here. So again, I'm guessing this helps to control how much power is going to the motor coils to spin that fan at different speeds. So now my job is to repackage this. But I just want to take a moment to appreciate the product as it was before I finished destroying it.